Welcome back. SAT Math question of the day, question number 8. The figure above shows a portion of the graph of the function f. If f of x plus 5 equals f of x for all values of x, then f of x equals 0 for how many different values of x between 0 and 12? Okay, so this isn't actually that difficult of a question mathematically, but I think the wording of the question and the weird looking graph is what throws people off, because it's not really a typical pre-calculus or calculus or trigonometry or geometry question where you have a formula and have a set of rules that you have to apply to get to an answer. This is part logic, but more than that, it's just reading through the question really carefully, not getting tripped up, and answering it correctly. So first of all, the first thing we want to figure out is, what is the question actually asking us? And it's asking us how many different values of x exist such that f of x equals 0 between 0 and 12. So when does f of x equal 0? So f of x equals 0 when the function crosses the x-axis. What we're essentially saying here is, hey, what values exist when plugging in an x value gives us a y value of 0? When does it cross the x-axis? And how many of those values are different? How many different values exist between 0 and 12? So we have the function shown to us between 0 and 5, and between 0 and 5 we have 4 x-intercepts. In other words, values where f of x equals 0. Again, this isn't necessary to answer the question. We're not necessarily solving for the x-intercept. We're really just counting values where f of x equals 0. And now the other part of the question is, well, how many of those exist between 5 and 12? Because we want all of the x-intercepts between 0 and 12. And that's when the first part of the question is really helpful and really necessary. It says, if f of x plus 5 equals f of x for all values of x, then how many x-intercepts do we have between 0 and 12? So if you notice here, they're starting to give us a clue and showing us basically what was stated in the question, which is after 5, the function starts repeating itself every 5 extra units. So from 0 to 1, we have this straight line, probably around -1, but we're not really told. And similarly, from 5 to 6, 5 being 0 plus 5, 6 being 1 plus 5, we have that portion of the function repeat itself. So from, say, 6 to 7, just drawing it out here, we would expect the function to repeat itself again, similar to the way, or exactly like the way it does between 1 and 2. And we would have an additional x-intercept like the beginning of the graph between 1 and 2. So we can break down 5 and 12 into two portions, 5 and 10, and 10 and 12. Why do we do this? Well, we know, based on what we're seeing here and based on this formula, that the function between 0 and 5 is going to look exactly the same as it does between 5 and 10, because f of x plus 5 equals f of x. F of 0 plus 5 is f of 5. F of 5 plus 5 is f of 10. So if we have four x-intercepts, or four values for f of x equals 0 between 0 and 5, we should also expect there to be four of those between 5 and 10. And for the portion between 10 and 12, well, that's going to behave similar to f of 0 to f of 2, because f of 10, in other words, is f of 5 times 2 plus 0. So we would expect the function between 10 and 12 to look like it does between 0 and 2, where there's one x-intercept. So here we would have one x-intercept, or in other words, a value where f of x equals 0. So adding all of these up together, we have 4 plus 1, which gives us 9, which is our correct answer. So really it's a counting problem, seeing how many x-intercepts there are between 0 and 5, and then a repetition problem where the question's telling us that between 5 and 10 and 15, and so on, for all values of x, after 5, the function mirrors itself. It looks exactly like it did before the value of 5. And so really it's a matter of counting, and also noting that we're not going up to 15, we're going up to 12, which means that between 10 and 12, this is the only additional part of the function that we expect to see, where there's only one additional x-intercept on top of the 4 and the 4 that we got from f of 0 to f of 10. So the correct answer is B. I know that's a longer question to explain, but I think with a close reading on test day, alongside trying to visualize this using the graph, it's a question that's not too difficult to answer mathematically, and hopefully you get to an answer quickly as well, so that you are able to complete the whole section in time. For more one-on-one SAT tutoring, check out the link in the bio. And for more videos, subscribe to the channel.